Photograph a historic site, help Wikipedia, and win a prize. Participate in the world's largest photography competition this month. Learn more. Centriole. 61 languages. Cell biology. Centrosome. Components of a typical centrosome. 1 centriole. 2 mother centriole. 3 daughter centriole. 4 distal ends. 5 distal appendages. 6 subdistal appendages. 7 proximal ends. 8 microtubule triplets. 9 interconnecting fibers. 10 microtubules. 11 pericentriolar material. See also, centrosome. In cell biology, a centriole is a cylindrical organelle, composed mainly of a protein called tubulin. 1. Centrioles are found in most eukaryotic cells, but are not present in conifers, pinophyta, flowering plants, angiosperms, and most fungi, and are only present in the male gametes of charophytes, bryophytes, seedless vascular plants, cycads, and ginkgo. 2. 3. A bound pair of centrioles, surrounded by a highly ordered mass of dense material, called the pericentriolar material, PCM. 4. Makes up a structure called a centrosome. 1. Centrioles are typically made up of 9 sets of short microtubule triplets, arranged in a cylinder. Deviations from this structure include crabs and Drosophila, melanogaster embryos, with 9 doublets, and Caenorhabditis elegans sperm cells and early embryos, with 9 singlets. 5. 6. Additional proteins include centrin, senexin and tectin. 7. The main function of centrioles is to produce cilia during interphase and the aster and the spindle during cell division. History, edit. The centrosome was discovered jointly by Walther Fleming in 1875, 8, 9, and Edouard van Beneden in 1876. 10, 9. Edouard van Beneden made the first observation of centrosomes as composed of 2 orthogonal centrioles in 1883. 11. Theodore Bovry introduced the term centrosome in 1888, 12, 9, 13, 14, and the term centriole in 1895. 15, 9. The basal body was named. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. Cross-section of a centriole, showing its microtubule triplets. A mother and daughter centriole, attached orthogonally. 3D rendering of centrioles, by Theodor Wilhelm Engelmann in 1880. 16, 9. The pattern of centriole duplication was first worked out independently by Etienne de Haven and Joseph G. Gall c. 1950. 17, 18. Role in cell division, edit. Centrioles are involved in the organization of the mitotic spindle and in the completion of cytokinesis. 19. Centrioles were previously thought to be required for the formation of a mitotic spindle in animal cells. However, more recent experiments have demonstrated that cells whose centrioles have been removed via laser ablation can still progress through the G1 stage of interphase before centrioles can be synthesized later in a de novo fashion. 20. Additionally, mutant flies lacking centrioles develop normally, although the adult fly cells lack flagella and cilia, and as a result, they die shortly after birth. 21. The centrioles can self-replicate during cell division. Cellular organization, edit. Centrioles are a very important part of centrosomes, which are involved in organizing microtubules in the cytoplasm. 22. 23. The position of the centriole determines the position of the nucleus and plays a crucial role in the spatial arrangement of the cell. Fertility, edit. Sperm centrioles are important for two functions. 24. 1. To form the sperm flagellum and sperm movement, and 2. For the development of the embryo after fertilization. The sperm supplies the centriole that creates the centrosome and microtubule system of the zygote. 25. Ciliogenesis, edit. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. Electron micrograph of a centriole from a mouse embryo. In flagellates and ciliates, the position of the flagellum or cilium is determined by the mother centriole, which becomes the basal body. An inability of cells to use centrioles to make functional flagella and cilia has been linked to a number of genetic and developmental diseases. In particular, the inability of centrioles to properly migrate prior to ciliary assembly has recently been linked to Meckel-Gruber syndrome. 26. Animal development, edit. Proper orientation of cilia via centriole positioning toward the posterior of embryonic node cells is critical for establishing left-right asymmetry during mammalian development. 27. Centriole duplication, edit. Before DNA replication, cells contain two centrioles, an older mother centriole and a younger daughter centriole. During cell division, a new centriole grows at the proximal end of both mother and daughter centrioles. After duplication, the two centriole pairs, the freshly assembled centriole is now a daughter centriole in each pair, will remain attached to each other orthogonally until mitosis. At that point the mother and daughter centrioles separate dependently on an enzyme called separase. 28. The two centrioles in the centrosome are tied to one another. The mother centriole has radiating appendages at the distal end of its long axis and is attached to its daughter at the proximal end. Each daughter cell formed after cell division will inherit one of these pairs. Centrioles start duplicating when DNA replicates. 19. Origin, edit. The last common ancestor of all eukaryotes was a ciliated cell with centrioles. Citation needed. Some lineages of eukaryotes, such as land plants, do not have centrioles except in their motile male gametes. Centrioles are completely absent from all cells of conifers and flowering plants, which do not have ciliate or flagellate gametes. 29. It is unclear if the last common ancestor had 1, 30, or 2 cilia. 31. Important genes such as centrins required for centriole growth are only found in eukaryotes, and not in bacteria or archaea. 30. Etymology and pronunciation, edit. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. The word centriole, /centriole/ uses combining forms of centri and ole, yielding little central part, which describes a centriole's typical location near the center of the cell. Atypical centrioles, edit. Typical centrioles are made of 9 triplets of microtubules organized with radial symmetry. 32. Centrioles can vary the number of microtubules and can be made of 9 doublets of microtubules, as in Drosophila melanogaster, or 9 singlets of microtubules as in C. elegans. Atypical centrioles are centrioles that do not have microtubules, such as the proximal centriole like found in D. melanogaster sperm. 33, or that have microtubules with no radial symmetry, such as in the distal centriole of human spermatozoon. 34. Atypical centrioles may have evolved at least 8 times independently during vertebrate evolution and may evolve in the sperm after internal fertilization. Evolves. 35. It wasn't clear why centriole become atypical until recently. The atypical distal centriole forms a dynamic basal complex, DBC, that, together with other structures in the sperm neck, facilitates a cascade of internal sliding, coupling tail beating with head kinking. The atypical distal centriole's properties suggest that it evolved into a transmission system that couples the sperm tail motors to the whole sperm, thereby enhancing sperm function. 36. References, edit. 1 AB Eddy, B. Rossier, J. Lerkaya, J.P. Desprez, E. Gross, F. Dinoulet, P. 1990. Post-translational glutamylation of alpha-tubulin. Science. 247, 4938 83-5. Bibcode, 1990 SCI, 247, 83E. Do. 10.1126/science.1967194. PMID 1967194. 2 Quamby, L.M., Parker, J.D., 2005. Cilia and the Cell Cycle. The Journal of Cell Biology. 169, 5. 70710. Do. 10.1083/JCB.2005030353. PMC 2171619. PMID 159282006. 3 Silflo, C.D., Lefebvre, Pa. 2001. Assembly and Motility of Eukaryotic Cilia and Flagella. Lessons from Chlamydomonas reinhartii. Plant Physiology. 127, for 1507 do. 10.1104/pp.010807. PMC 1540183. PMID 117430994. 4 Lewo, Stefan, Haysken, Monica, Gupta, Gargan D. Pelletier, Lawrence, November 2012. Subdiffraction imaging of centrosomes reveals higher-order organizational features of pericentriola. Material. Nature Cell Biology. 14, 11 1148 1158 do. 10.1038/NCB 2591. ISSN 1476-4679. PMID 23086-237. S2 SID 11286303. 5 Delattre, M. Gonchi, P. 2004. The Arithmetic of Centrosome Biogenesis, PDF. Journal of Cell Science. 117, pt 9 1619 30 do. 10.1242/jcs.01128. PMID 15075224. S2 SID 7046196. Archived, PDF, from the original on the 18th of August 2017. 6 Lydell, S. Delattre, M. Cerruti, L. Baumer, K. Gonchi, p. 2005. SAS6 defines a protein family required for centrosome duplication in C. elegans and in human cells. Nature Cell Biology. 7, 2115. 25 to 10.1038 / NCB 1220. PMID 15665853. S2 SID 46343552. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. 7 Reader, CL. Faruqi, S. Khojakov, A. October 2001. The centrosome in vertebrates, more than a microtubule organizing center. Trends in Cell Biology. 11, 10.413419 do. 10.1016 /S0962. 8924, 01, 02085-2. ISSN 0962-8924. PMID 11567874. 8 Fleming, W. 1875. Studien über die Entwicklungsgeschichte der Nageden. Sitzungsgeber. Aked. Wis. Wien 71, 81147. 9 ABCDE Bloodgoodra. From central to rudimentary to primary, the history of an underappreciated organelle whose time has come. The primary cilium. Methods Cell Biol. 2009, 94:3-52. Do. 10.1016 /S0091-679X, 08, 94001-2. EPUB 2009 23 December. PMID 20362083. 10 Van Beneden, E. 1876. Contribution à l'histoire de la vésiculaire germinativite du premier noyé embryonnaire. Bull. Acad. A. Belg, 2 Me Series, 42, 3597. 11 Wunderlich, v. 2002. JMM, Past and Present. Journal of Molecular Medicine. 80, 9545548. Do. 10.1007 /S00109-002-0374Y. PMID 12226736. 12 Bovry, T. 1888. Zellenstudien 2. Die Befruchtung und Teilung des Eis von Ascaris. Megalocephala. Jana. Z Nature Wis. 22, 685882. 13 Bovry, T. Über das Verhalten der Centrosomen be der Befruchtung des Eigeles nebst. Allgemeinen Bemerkungen über Centrosomen und Verwandts. V. D. PHYS Med. Giz. Zoo. Verberg, NF, BD. X6, 1895. Link. 14 Bovry, T. 1901. Zellenstudien, über die Nature der Centrosomen. 4. Fisher, Jana. Link. 15-carat Bovry, T. 1895. Über die Befratungs- und Entwicklungsfähigkeit können Loser sie Iglia und über die Möglichkeit ihrer Bestätigung. Arch. Entwicklungsmög. Org. Wilhelm Rue, 2, 394443. 16-carat Engelmann, T.W. 1880. The Anatomie und Physiologie der Flimmertellen. Flügers Arch. 23, 505. 535. 17-carat Wolf, Stephen L. 1977. Biology, The Foundations, 1st ed. Wadsworth. ISBN 9780534004903. 18-carat Vorabjv, Iadot, Nadijdina, E.S. 1987. The centrosome and its role in the organization of microtubules. International Review of Cytology. Volume 106. pp. 227293. Do. 10.1016/S0074. 7696, 08, 61714-3. ISBN 978-0-12-364506-7. PMID 3294718. See also de Haven's own. Recollections of this work, de Haven, et.en., 1994. Early observations of centrioles and mitotic spindle fibers by transmission electron microscopy. Biology of the Cell. 80, 23107109. Do. 10.101768.322x.1994.tb00916.x. PMID 8087058. S2 SID 8459460. 19-carat AB Salisbury, J.L., Suino, Kilometer, Busby, R., Springet, M., 2002. Centrin 2 is required for centriole duplication in mammalian cells. Current Biology. 12, 15 1287 92 do. 10.1016/S0960. 9822, 02, 01019-9. PMID 12176356. S2 SID 14155623. 20-carat La Terra, S, English, C.N., Hergert, P, McEwen, B.F., Sluder, G, Kojakov, O, 2005. The de novo centriole assembly pathway in HeLa cells, cell cycle progression and centriole assembly /maturation. The Journal of Cell Biology. 168, 571322 do. 10.1083/JCB.2004111126. PMC 2171814. PMID 15738265. 21-carat Baso, R, Lau, J, Vinogradova, T, Gardial, O, Woods, C.G., Kojakov, O, Raf, J.W., 2006. Flies without centrioles. Cell. 125, 7 1375-86 do. 10.1016/J.Cell.2006.05.025. PMID 168147222. S2 SID 20806884. 22 Feldman, J.L., Geimer, S., Marshall, W.F., 2007. The mother centriole plays an instructive role in defining cell geometry. PLOS Biology. 5, 6E149 10.1371/journal.bio.0050149. PMC 1872036. PMID 175185519. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. 23 Beeson, J. Wright, M. 2003. Basal body /Centriole assembly and continuity. Current opinion in cell biology. 15, 196-104 do. 10.1016/S0955-0674-02-00017-0. PMID 1251771. 24 Avidaris, T. Kaya, A. Fishman, E. L., and Joe, K. H. 2015. Atypical centrioles during sexual reproduction. Frontiers in Cell and Developmental Biology, 3, 21. Chicago. 25 Hewitt-Son, Laura and Scotton, Gerald P. 2003. The Biology of Fertilization in Humans. In Patrizio. Pasquale, et al. eds. A Color Atlas for Human-Assisted Reproduction, Laboratory and Clinical Insights. Lippincott Williams and Wilkins. p3. ISBN 978-0-7817-3769-2. Retrieved 9 November 2013. 26 Kui, Cheng, Chatterjee, Bishwanath, Francis, Dian, Yu, Jing, San Augustine, Jovenel T. Francis. Richard, Tansey, Terry, Henry, Caris, Wang, Bowlin, Lemley, Beth Ann, Parza, Gregory J. Lowe, Cecilia. W. 2011. Disruption of MKS1 localization to the mother centriole causes cilia defects and developmental malformations in Meckel-Gruber syndrome. Dis. Models McC. 4, 14356. Do. 10.1242/DMM.0062662. PMC 3008963. PMID 210452111. 27 Babu, Deepak, Roy, Sudipto, 1 May 2013. Left-right asymmetry, cilia stir up new surprises in the node. Open Biology. 3, 5 130,052 do. 10.1098/ASOB.130052. ISSN 2046-2441. PMC 3866868. PMID 237205541. 28 Su, M.F., Stearns, T. 2006. Mechanism limiting centrosome duplication to once per cell cycle. Nature. 442, 7105 94751. Bibcode, 2006 Nature.442947T. Do. 10.1038/Nature 04985. PMID 16862117. S2 SID 44132448. 29 Marshall, W.F. 2009. Centriole evolution. Current opinion in cell biology. 21, 11419. Do. 10.1016/j.seb.2009.01.008. PMC 2835302. PMID 191965504. 30 AB Bornins, M. Azimzade, J. 2007. Origin and evolution of the centrosome. Eukaryotic. Membranes and cytoskeleton. Advances in Experimental Medicine and Biology. Volume 607. pp. 119. 129. Do. 10.1007/9780387740218_10. ISBN 978-0-387-74020-1. PMID 179776464. 31 Rogozin, IB. Baju, MK. Xiros, M. Kunin, EV. 2009. Analysis of rare genomic changes. Does not support the unicant-bicant phylogeny and suggests cyanobacterial symbiosis as the point of primary radiation of eukaryotes. Genome Biology and Evolution. 1, 99113. Do. 10.1093/GBE/F011. PMC 2817406. PMID 20333181. 32 Avidaris, Toma, Gopalakrishnan, Jayachandran, 2013. Building a Centriole. Current opinion in cell biology. 25, 172.7 Do. 10.1016/j.seb.2012.10.016. PMC 3578074. PMID 231999753. 33 Blachon, S, CAI, X, Roberts, K. O, Young, K. Polyanovsky, O, Church, O, Avidaris, T. 2009. O. Proximal centriole-like structure is present in Drosophila spermatids and can serve as a model to study centriole duplication. Genetics. 182, 113344 Do. 10.1534/genetics.109.101709. PMC 2674812. PMID 1929339. 34 Fishman, Emily L., Jo, Kyung, Nguyen, Quinn Ph., Kong, Dong, Roifman, Rachel, Sekik, Anthony R., Canal, Sushil, Miller, Ann L., Simile, Calvin, Scotton, Gerald, Lonkerek, Chadrankar, Menela, Vito. Avidaris, Toma, 2018. A novel atypical sperm centriole is functional during human fertilization. Nature Communications. 9, 12210. Bibcode, 2018 Natco, 9.2210f. Do. 10.1038/S41467-018. 04678-8. PMC 5992222. PMID 2988080. 35 Turner, K. N. Solanki, H.O. Salaha, and T. Avidaris. 2022. Atypical centriolar composition. Correlates with internal fertilization in fish cells. 11:758 https://www.mb.com/2073-4409/11/5/758 36 Canal, S. M.R. Lang, A. Roifman, E. L. Fishman, B. Saltzman, H. Bloomfield Gadala, T. Zeev, Ben Mordechai, and T. Avidaris. 2021. A dynamic basal complex modulates mammalian sperm movement. Natkamyan. 12:3808 https://do.org/1038//S41467-021-24011-0. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF. Categories: Centrosome protein complexes, cell movement. Explore our developer-friendly HTML to PDF API printed using PDF Crowd HTML to PDF.